Hello, my name is Amina Dasuki, and this is the video presentation for Chapter 9. The main topic is combination of functions, but my main focus will be on selecting a strategy to combine functions by addition. I chose this topic because I want to know how to plot so many functions on a single graph sheet, and it is also very interesting, and I would like to learn more about it. It is often used to describe curves and lines on a coordinate graph, as a function shows the relationship between x and y coordinates. A real life use is a combination of functions is often used to model the way that a contagious disease spreads. So you will need a graph book when two functions you then so the teaching process of this is when given two functions to add, first draw up the individual functions to see their behavior. Secondly, add the functions together and plot the final answer. You then highlight on key characteristics of the resulting graph. So we are given, this is the graphical strategy. After the graphical strategy, I will show the algebraic strategy as well. So we are given these two equations. F of x is equals to x plus 3 and h of x is equals to 2x. If you put each x value into the equation, you'll get the values for f of x, which I've done previously to speed up the presentation. So, for instance, when put in f of x, so your answer will equal to minus 3 squared plus 3. Your answer will give you minus 6. Same thing applies here. So minus 3 into, so 2x. So that will be 2 times minus 3. Your answer will equals to 6. Okay. And then you then go on to add these two to find f of x plus h of x. So your answer will minus 6 will be 12, minus 4 minus 1 plus minus 1 will equals to minus 5, and so on. Also, to speed up time as well, I've gone ahead to plot the graph for these so the presentation doesn't go on. This is what the line of f of x, this is the line of f of x is equals to minus x squared plus 3. This is the graph for f of x plus h of x, and this is a line for h of x is equals to x. You, of course, before drawing this, you pick a suitable scale where all numbers will fit into onto your graph paper, and then you go on to draw, and then you draw a line of best fit through the points. The observation here is the zeros of the new function occurs when the y values of the f and h are the same distance from the x-axis on different sides, and any point where f and h intersect, the value of f and h is double the value of f or h for the corresponding x. It has zeros at 1, minus 1, 10, and 3, 0. Using the algebraic strategy, f of x is equals to minus x squared plus 3, and h of x is equals to 2x. Add the two functions, so f of x plus h of x. Your answer will equals to x minus x plus 3 plus 2x. So, minus x squared. So this it gives you a quadratic equation. In the form of ax bx plus c. So x squared minus x squared plus 2x plus 3. So this is f of x plus h of x. Completing the squares, you go on to minus x squared plus 2x plus 3. you take out minus 1 outside the bracket, so minus 1x squared minus 2x minus 3. If you multiply out the bracket again, you will get the same thing. So minus 1x squared minus 2x plus minus 1 squared minus 1 squared minus 3. So your answer will equals minus 1 x minus 1 squared minus 1 minus 3, which will give you minus 1 bracket x minus 1 squared minus 4. So therefore we have minus 1 x minus 1 squared minus 4. So your answer will equals minus 1 x minus 1 squared plus 4. The graph of f plus h can be sketched by starting with the graph of y is equals to x squared. So y is equals to x squared. You then go on to plot the points for this. So we will be starting minus 3, minus 2, minus 1, 0, 1, 2, 3. So your answer for this, when put, so this is x and this is y. So minus 3 squared is 9, minus 2 squared is 4, minus 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. And applying the following transformation, reflection in the x-axis is followed by a shift of 1 unit to the right and 4 units up. So you then go on to plot the graph. You find I've gone ahead to plot the graph beforehand as well. So this is the line for y is equals to x squared, and this is the line for h of x plus y of x, which you will also work out the values for. And the observation is that the new graph has the following characteristics. It is increasing on the interval of minus infinity 4 and decreasing at the interval of 4 infinity. So minus infinity 4 and 4 infinity. It has zeros at minus 1, 0, and 3, 0. It has a maximum at 4 at x is equals to 1, and the domain is equals to x is known as x is the element of all real numbers, and the range is equals to y is that of y is the element of all real numbers, or y is less than or greater than 4. Thank you.